Hello guys, so now I'm going to explain to you all about the working procedure in solving the problems of Laplace transform. This is the working procedure. Okay, so this is the working procedure for solving the Laplace transform. I think I'm having a problem with this blur issue, not so clear. I hope you all bear that with me. Now, working procedure. So let us start with step 1. Step 1. What is this step 1? In a problem, to solve it, there are many steps, but the basic steps are these. So what are these basic steps? In the question, they will give some kind of a question in the form of this. If f of t, they'll ask you like that in the question. If f of t, find L into f of t, something f of t, that, this and all. So now they'll ask you like this. Find L into f of t if f of t is equal to f1 of t, comma 0 less than t less than a. Next line, f2 of t, comma 0 less than t less than b. Next line, f3 of t, comma t greater than b. Okay, so this is how it is. They will ask you like that in the question. Find L into f of t is f of t is equal to f1 of t 0 less than t 0 less than a, f2 of t 0 less than t less than b, f3 of t greater than b. Now we will consider the basic definition of L into f of t. What is the basic definition of L into f of t, which I told you all in the previous session, is that you must remember the basic definitions of all the modules when you solve a problem, because this is how you apply the definition first. Now you will apply the definition. L into f of t, the definition of Laplace transform, L into f of t is equal to integral 0 to infinity e to the power of minus st into dt. Okay, so this is the definition of Laplace transform. They'll ask you in the question, find L into f of t if f of t is equal to something, that, this and all, and then you will apply the definition. L into f of t is equal to integral 0 to infinity e to the power of minus st into dt. Okay, so now this is the step 1. This is the step 1. Now we'll go to the step 2. What is this step 2? Step 2 is very simple. Okay, you need to just apply it. I'll show you how. Remember, my dear students, this is just, you're not only my dear students, you're also my friends, because I'm also still a student like you, studying in Raimek College, which is in Ballari. So I'm still a student. I'm still supposed to go to the college and show my face, but it has become very tough time for me for not finding that time to go and do that. Now what I am telling you all is the step 2. Step 2. So the step 1 is if f of t, there will be a bracket like this, this is equal to, okay, please forgive my unclean expressive of showing this brackets. Okay, so f of t is equal to f1 of t 0 less than t less than a, f2 of t 0 less than t less than b, f3 of t t greater than b. Now you will apply the definition. L into f of t is equal to integral 0 to infinity e to the power of minus st into dt. Okay, so that is done. Now comes the step 2. Therefore in step 2, L into f of t is equal to, now comes the real issue. How do you take this in step 2 and apply that? Now comes the real issue. This is how you're gonna do it. That is integral, what is the definition? 0 to infinity, nothing but this first a to 0. I'll show you all how to use these kind of things in step 2. First I'll just write it down. Okay, I'll explain to you all. I'll just write it down. So the definition is this and the given is this. Now comes the step 2. L into f of t. What is there in the given? 0 less than t less than a. Let us put that. A 0. Okay. Now e to the power of minus st into f1 of t into dt. This is the first row. Now comes the second row. Take this, look at the definition and add, plus integral a to b e to the power of minus st into what is given here, f2 of t. I'm very sorry my dear friends, I think I have made a mistake over here. It is f of t into dt. Please forgive my mistake, but you have to forgive me because I am also a student like you. Now here comes, now this is given f2 of t into dt. Okay, so this is finished. Now comes the last row, plus, where is that? Here it is, plus integral, what is given here, t greater than b. I'll explain you all how to put these things like this. Okay, so we will write infinity to b e to the power of minus st into f3 of t into dt. Okay, so this is the step 2. Okay, so I'll come again from the beginning. Working procedure for solving the Laplace transform. So this is something like this. They will ask you find L into f of t if f of t is equal to this, that and that. So this is what they have given. Now you will Remember, and you will write, we know that L into f of t, that is the basic definition of Laplace transform, is equal to integral 0 to infinity e to the power of minus st into f of t into dt. Okay, that is the step 1. Now the step 2. Therefore L into f of t is equal to, now everyone, not everyone, some students will get confused. How do you put 0 to a here but not b to, infinity to b? Some confusion will be around some 10% of the students. I'll give you the solution. Okay, so now what I have done is, I will take pencil, no pen, I will take red pen. Okay, so that it will be some kind of explanation. Okay, now see, this is a, okay, this is a, and this is 0. We have less than and less than over here. This is also less than and less than over here, but here it's something different. It is something different. It is greater than. So what I said, we have 0 and a, and we have less than and less than over here. Okay, so how do you take this? You take this up, okay, and you keep like this you keep. How? A, and bring it, and bring this one down like this, go down. Okay, like this, go down, and you bring it over here. 0, you put integral, that's it. Okay, that is what I have done here. I have taken a up and I have kept 0. Okay, so that is finished. What is this one? Another given they have given, f1 of t. We have seen the definition, L into f of t is equal to integral e to the power of minus st into f of t. Here it is that f of t. So take this f1 of t and put it over here. In the second line, take this f2 of t and put it in the other here. And in the third line, take this f3 of t and put it over here. Simple. Okay, so I was explaining you all about this. 0 less than t less than a, you take like this, some kind of shortcut display to help you all with some confusion. Now you take like this, you put like this a and you put 0. In the same way, take this and send this up, and from up you put like this b and you put 0 and write integral. Finished. See, I have written b and a, and I have written integral b a, and I have written integral. Now comes the different issue. See, here it was less than, here also less than, but this one is looking very different. This is greater than. So this will be interesting. Okay, you will take this one down, that will become here b, but here it will be infinity. You write integral, that's it. That is what I have written here, infinity b integral. Okay, so now I have taken this one down, that is b here, and this is infinity. I have written integral. Okay, so this is how it is. Now so this is the step 2. This is the step 2. What is in step 1? They will ask you in exam, find L into f of t. Find L into f of t. if f of t is that, this and that and that, f of t is equal to this one, they will give you this given. Okay, now you will start answering. You will write, we know that, we remember that the basic definition of Laplace transform, that is L into f of t is equal to integral 0 to infinity into e to the power of minus st into f of t into dt. Okay, this you will write that we know that. Now you will write, not you won't write, but this is the step 2. How do you take the step 2? Therefore L into f of t is equal to integral 0 to a e to the power of minus st into f1 of t into dt. How did you write this? We have got here given f1 of t 0 less than t less than a, and we have taken that and put it here, a to 0 e to the power of minus st f1 of t. Here it is f1 of t. Okay, so now the other row here, this row, we'll solve this row. Okay, how do you take that? You will look at the definition and you will write integral a b to a e to the power of minus st into f of f2 of t into dt, that is here from the given. Now comes the last row. This last row will always be different, it will be like something greater than. So f3 of t, here we'll take that, we will look at the definition and we will write integral infinity to b e to the power of minus st into f3 of t dt, f3 of t, and write this. So this red color things I have explained you all, please look carefully in the video. Okay, so now this is done, this is also done, this is also done. Okay, this is the step 2. So I think we have finished the all required steps. Okay, I think we have only 2 steps as far as I am concerned, and the way I have prepared over here, the way I have prepared over here, this is how I have prepared. Sorry for the blur issue. Okay, so now there are only two steps. So like I said, in every problem there will be puzzles. This is what engineering is all about, puzzles, not studies, it's only puzzles. So you must solve that puzzle. To solve that puzzle, you must remember some extraordinary notes and extraordinary formulas. So now I have explained you all about the working procedure of the Laplace transform solving. This is step 1 and this, therefore step 2 and this and this and this. Now comes the notes of the, sorry, where is my pen? Here it is. Notes of the working procedure. There are many notes, but I will tell you all one. In the coming problems when I explain, I will tell you all everything. Okay, so now the note number 1. What is this note number 1? We have here, that is something called Bernoulli's generalized rule. How do you apply this rule? When in solving the problem, you will have like this. Here I'll write, okay, as a rough figure here. Okay, in problems they will give you something like this: integral something to something, infinity to something. Okay, this one consider. Okay, now e to the power of minus st, they will give you constants, say like 2 constants into dt. When you look at the constant and a function, you cannot apply the Bernoulli's rule, because this is a constant and this is a function. So there is only one function, no second function, because this is a constant and this is a function. Therefore there is only one function, not 2 functions. This is not a function, this is a constant. Okay, that is one example. Now other example how they ask you in V2 exams is this. Example number 2. Here this is how they'll ask, this is how you will come across. This is something to something, consider infinity to 0. Now this is how it will be. In e to the power of minus st into some function say like sine 2t into dt. So look at here, we have two functions. This is first function and this is second function. So now we have a problem. Now the time has come for us to use some extraordinary formulas. What is that one of those extraordinary formulas? That is the Bernoulli's rule. Note number 1, the formula of Bernoulli's, where is this rule? Okay, this is what it is. Now this is the Bernoulli's rule. When will you apply this rule? When you have this kind of things. Integral e to the power of minus st into f of t into dt. This is just an example, okay, just an example. Okay, integral e to the power of, so we have one function. Now this is how we must remember one important things, my dear friends. You cannot, okay, so this is how you'll come across e to the power of minus st into f of t dt, but you must little bit amplify it like this. Integral f of t, you must write this over here and this over here like this, f of t into e to the power of minus st into dt. Okay, so now this will become two functions, that is u and v. Now comes the Bernoulli's rule formula. This is the formula. What is the formula? Integral uv into dt. Where is this uv? Where is this uv? Here it is. uv into dt is equal to where is the, here is equal to u integral v dt. Okay, nothing but minus u dash double integral v dt. Okay, plus w dash triple integral. Okay, triple integral. 1 second please, just hold on. Triple integral. Okay, triple integral. 1 integral, second integral and triple integral. Nothing but v into dt into dt into dt minus minus 0, no, minus and so on forever. Not forever, there will be a 0. Not everything is infinity, some are infinity. Okay, so this is the Bernoulli's rule. These kind of extraordinary formulas you are supposed to use in a puzzling problems. Integral u v dt, u integral v dt minus u dash double integral v dt dt plus u double dash triple integral v dt dt dt. So this is This concludes the end of this session, that is the working procedure. This is the step 1 and this is how it is, and this is the formula, the basic definition. Now comes the step 2 and you will apply all those given data in this form, and while solving problems you will come across some puzzles. To solve such puzzles you must use some puzzling formulas such as Bernoulli's rule, and that rule is something like this: integral u v dt, u integral v dt minus u. Okay, that one. And that concludes this session. I'll come again online back to the next session. Bye my dear friends.